All right, students, here we go. I would definitely find a picture that looks like this and put it in your notes, or kind of make a notation somewhere in your notes of these different types of end behavior that match up with the degree of your polynomial function. And really, I have so much more to tell you about these polynomial functions, and what this a value right here can tell you, and what this n value can tell you about the number of solutions, either real or imaginary. So we're going to just touch on end behavior today. And then when we get to our unit on polynomial functions, we're going to expand on this idea of really analyzing this a value you see right here, your leading coefficient. Okay, that leading coefficient is going to tell you a lot about your function, right? And also the degree, this n value right here. So the a value, and then the n value in this case is the degree of your polynomial function. Okay, so remember, the degree of your function can be an even number or an odd number, not to be confused with symmetry. All right, so we're going to take a look at what happens and how this end behavior is classified. And this is going to be always the case. It's pretty cool. No matter what n is, in this case, it looks like a quadratic. So our n value is probably squared, right? It's x to a squared value. But these n behaviors apply anytime n is even. Okay, right here where you see n is even. And when n is even, you either have an opening up, left and right hand behavior, or opening down together, left and right hand behavior. And the way you know whether it is opening up or opening down would be based on your leading coefficient, right? So if your leading coefficient is negative, right, this one, it's less than 0, that means it's negative, then you know that your graph has an n behavior going to negative infinity, right? So as x approaches negative infinity, that's what this is saying right here, then your y value is also approaching negative infinity. And here it is right here. Okay. Similarly, if your x is approaching infinity, that means as your x values are going to infinity, your y values are approaching negative infinity. And that happens if your a value is negative. So if n is even degree, a is negative. And then similar reasoning here, if your a value is positive, so if it's greater than 0, as x approaches infinity, y is approaching infinity. So we have this notation. You see how that notation looks? That's what I'm looking for right there. And as x approaches negative infinity, your y actually this time approaches infinity. And you see the notation coming about right there. So either both opening up or both opening down, and that is for an even degree. Okay. Good. Okay, we're going to play with these A, B, C, D here and on the right side of your screen in just a minute. Before we do, let's go on and kind of round out these n behaviors very quickly with what happens if you have an odd degree. So what if n is odd? Okay, if n is odd, and that would be like a linear function. A linear function is odd, has an, because it's like y is equal to ax plus b. Your degree here is 1. 1 is an odd number, so a linear function would have an odd degree. These that you're looking at here probably have a cubed. It's probably an ax cubed of some kind. right? And it doesn't matter if it's cubed or to the 5th or to the 7th. If n is odd, okay, and your a value is greater than 0, that means it's positive, right? Then you are going to be opening down to the left and up to the right. So the way we talk about that, remember, in terms of notation, is as x goes to negative infinity, your y value is going down to negative infinity as well, right? And similarly, as x goes to infinity, your y value goes to infinity. Right here, what changes? Your a value is now negative, all right? So your leading coefficient is now negative, n is still odd. You have the behavior of from negative infinity going to infinity, and as x goes to infinity, y goes to negative infinity, okay? So what you want to be able to do with this information is you want to be able to describe end behavior. These would be an odd degree. Or you might want to be able to look at a graph like this one in your graph A and go, oh, okay, I know first of all that this is an odd degree polynomial, so the degree of this polynomial is going to be 1 or 3, or probably not 1 because it has curves in it, more solutions than just 1. But it's going to have an odd degree, and the leading coefficient is negative because it kind of goes down from left to right. This one would be an odd degree, okay? So this one would be an odd degree, but this time the leading coefficient would be positive, for example. Here, because you are opening down, your end behavior is down on both sides. That would be an even degree polynomial function of some kind. And it would have a negative leading coefficient. This one, because it's opening up on both sides, would have an even degree polynomial, and it would be a positive leading coefficient. Okay? So when I'm asking for end behavior, this is what I'm asking you to give me. I'm asking you to analyze based on the leading coefficient and the degree of the polynomial what the end behavior will look like. And we'll practice this as well. Okay? So we're going to shoot on up here and look at an example of something that you might see. All right? And I don't really even need to graph this to be able to describe the end behavior. I know the leading coefficient is 1, so my a value is equal to 1. My degree is equal to 4, so I know it's going to be an even degree polynomial function, and it has a positive leading coefficient. So I know, there could be lots of stuff going on in here in the middle. It really doesn't matter right now that you're identifying these minimums and maximums for kind of where they are. What we're looking for is end behavior. So as x goes to infinity, y would go to infinity. As x goes to negative infinity, y goes to infinity. Okay? So take a look at this one. Maybe you want to pause the video right here. Wait a couple seconds. Okay, did you wait? Pause for a minute. See if you could describe this end behavior. My a value is negative. It's a negative 1. The degree of my function is odd. It's 3. So we're looking at this number right here, negative 1, and we're looking at this number right here, 3. So I know, just based on that information, and not sure about what's happening in the middle, but I do know that it will eventually be opening up to the left, and then it's going to go down to the right. Okay, so when we talk about end behavior, we have as x approaches infinity, your f of x is going to go to negative infinity. And as x approaches negative infinity, f of x will go to infinity. All right, guys, hopefully that is a great help as you continue your work in this particular section. You are doing great. Look at, I'm going to give you a great big smiley face for the day. All right, go get them, guys.